Okay, so we have to start with question number 4. Let's start. Aqueous bromine reacts with methanoic acid to form hydrogen bromide and carbon dioxide. So here we have our reactants and these are the products of this reaction. And here you have our equation provided over here. The table shows the oxidation number of bromine and carbon in the species involved in this reaction. So if you see, bromine's oxidation number changes from 0 to -1, which means it undergo oxidation. And further, I can conclude that, sorry, it changes from 0 to -1, which means it undergo reduction. And further, I can conclude that it is an oxidizing agent. The oxidation number of carbon changes from +2 to +4. It increases, which means it undergoes oxidation, and hence carbon is a, or methanoic acid is a reducing agent. Is this understandable to everyone? Now, what they are saying, identify oxidizing agent. So we have identified oxidizing agent, that is Br, bromine. In this reaction, explain your reasoning with reference to oxidation numbers. So what we are observing that its oxidation number is changing from 0 to -1, right? So we state the answer in the same way. First, I'm going to identify the oxidizing agent. So we are observing that bromine oxidation number changes from 0 to -1, which means its oxidation number decreases, hence it is reduced. So if bromine is reduced, which means bromine is oxidizing agent in this reaction, because now how I'm going to explain this? See, they have asked you that explain your reasoning with reference to oxidation number. Okay, so what we are observing that its oxidation number decreases. So I can write that bromine is an oxidizing agent in this reaction because its oxidation number decreases. Is this clear to everyone? Yes. Okay. Now let's move to the part B. Suggest one change you would observe ignoring temperature changes when bromine reacts with methanoic acid. So this change is so obvious if you remember or you know the color of halogens. We all know that bromine, it's an aqueous state, which means that the solution is orange. And when it becomes a part of a compound, then it becomes colorless. So that is the change that I have to write over here. So I can write the color of the solution changes from brown to colorless. Is this understandable to everyone?
Sir, orange or brown?
Okay. So I have written brown over here. Beside this brown, orange or reddish brown or red is also accepted by the examiner. Okay. Now, C part, this reaction can be followed by measuring the concentration of bromine present in the mixture at regular time intervals. The graph shows the change in concentration of bromine against time in a reaction carried out at 20 degrees Celsius. Now, what they are asking you, use the graph to calculate average rate of reaction at 20 degrees Celsius during the first 600 seconds, state units of this rate of reaction. So if anybody recall the rate of reaction, the expression for the rate of reaction, if you have to calculate the rate of reaction, so rate of reaction is equal to change in concentration over time taken in which the concentration is changed. So they ask you, they have given you the time, that the time is 600 seconds, right? Now, initially the concentration is 100 and at 600 seconds, the concentration is
16.
Are you sure it's 16?
12. Sorry. 12.
Isn't it 12? It's a 12. And here they have provided you times exponent 5, right? So what is the change when we recall? Change is always final minus initial, right? So the final concentration is 12 exponent 5 minus initial concentration is 100 exponent 5. And if it's a concentration, so the unit will be mole per dm cube. So can anybody solve and tell me the answer? Yes.
So initial minus the final.
Why initial minus final? देखें change जब भी होता है तो change हमेशा final minus initial होता है. देखें जब start हुआ तो उस वक्त 100 था ना. It's a 100 when it started, and when the time passes to 600, it's 12. Yes, can anybody tell me the value? The answer, please.
Sir, minus 14,666.
Minus 14,000.
666.
666. Okay. आप एक दफा क्रॉस चेक भी कर लें कोई और स्टूडेंट भी कि एग्जैक्टली यही वैल्यू आ रही है, और आप दोबारा कैलकुलेट करके देख लें।
सर यही वाली बात।
एक मिनट। ओके, तो अगर मैं इसे सिग्निफिकेंट फिगर्स में कन्वर्ट करूंगा तो ये क्या हो जाएगा, 1.47 एक्सपोनेंट -4, राइट। अच्छा, इधर एक इम्पॉर्टेंट बात आपको पता पता होनी चाहिए कि ये जो माइनस साइन है, दिस माइनस साइन इंडिकेट्स द डायरेक्शन। इसका मतलब ये नहीं है कि जो है ये नेगेटिव में वैल्यू है। इट इज इंडिकेटिंग द डायरेक्शन दैट द चेंज इज डिक्रीजिंग, चेंज इज नॉट इंक्रीजिंग, द रेट इज डिक्रीजिंग। तो जब आप आंसर कोट करेंगे तो इट डजंट नेसेसरी टू राइट द साइन अलोंग।
सर हमने
और
प्रीफिक्स में -4 क्यों लिखा है, मतलब 4 क्यों नहीं लिखा?
क्या आप रिपीट करेंगी दोबारा?
सर हमने प्रीफिक्स के अंदर -4 क्यों लिखा है?
-4?
प्रीफिक्स में 10⁻⁻⁴।
हाँ सॉरी, क्योंकि ये एक्सपोनेंट 5 है तो ये एक्सपोनेंट 4 हो जाएगा, नॉट -4। और यूनिट क्या होगा, मोल पर डीएम क्यूब पर सेकेंड। इज दिस क्लियर?
यस
Yes.
सर।
ओके, नेक्स्ट पार्ट। The experiment is repeated at temperature of 40 degrees Celsius. This relatively small increase in temperature produces a large increase in reaction rate. Okay, so the initial temperature was 20 degrees Celsius. That's what they have mentioned over here. Sketch a graph on the same axis to show the expected results when repeating the experiment at 40 degrees Celsius. तो रेट इंक्रीज होगा तो उससे आपके ग्रेडियंट पे क्या फर्क आना चाहिए, अगर रेट इंक्रीज हो रहा है हाई टेम्परेचर होने की वजह से, तो
ग्रेडियंट इंक्रीज करेगा।
More steep.
मोर स्टीपर हो जाएगा। बट एंड कहाँ पे होगा आपका कर्व, वहीं पे एंड होगा जहां पे अभी हो रहा है। ठीक है,
Time क्यों
तो
नहीं डिक्रीज?
जी
टाइम क्यों नहीं डिक्रीज होगा?
बेटा टाइम डिक्रीज होगा मतलब ये कि मैं 600 तक ही लेकर आऊंगा, मेरा कहने का मतलब ये है। जब आप यूं स्टीपर बनाएंगे, 1 मिनट, तो ऑब्वियसली आपका जो टाइम है वो तो डिक्रीज हो जाएगा, क्योंकि लाइन आपकी जो फ्लैट है हॉरिजॉन्टल जो है पहले हो जाएगी।
ओके सर।
ये मुझसे सही नहीं बन रहा, 1 मिनट बल्कि यहाँ से स्टार्ट करते हैं ना। तो इस तरह का आपका जो है वो बनेगा।
सर रफली बनाएंगे ना इसे?
जी
इसे रफली बनाएंगे ना?
हाँ, इसी तरह रफ सा बनाएंगे। आप एग्जैक्ट तो नहीं बना सकते क्योंकि आपको एग्जैक्ट फिगर्स नहीं पता। Okay, next part. The rate of a reaction increases when the frequency of successful collision between reactant particle increases. Explain why an increase in temperature produces this effect. So, we know when the temperature is increased, what happens to the energy of the particles?
इंक्रीज कर दिया।
Yes. And if this increases, then the proportion of the particles having energy equal to or greater than activation energy becomes more or greater, and that result in more successful collision, or the frequency of successful collision increase. So first I will state that energy of reactant particles increases due to increase in temperature. Hence, more proportion of particles have energy equal to and greater than activation energy. Yes, is this understandable to everyone? Okay. Complete the dot and cross diagram showing outer electrons only to show the bonding in methanoic acid. So if anybody have any difficulty in this, you can first draw the displayed formula, and displayed formula will help you to uh, identify the number of bond pairs between each atom. So between carbon and hydrogen, yes, between carbon and hydrogen, there is a one pair. Between carbon and oxygen, this oxygen, there is a one pair. And between oxygen and this hydrogen, there is a one pair. So oxygen have a two pair of electrons, and carbon with the oxygen that is at the top have a two pairs of electron because there is a double bond. So I will make two pairs over here and two lone pairs over there, like this. Is this clear to everyone?
जी सर।
Okay. Now question number 5. Naphtha is a mixture which contains only hydrocarbon molecules. What is meant by the term hydrocarbon? So it just tells us that there is a hydrogen and carbon, so we can write hydrocarbon is a compound containing carbon and hydrogen only. Next part. Name the raw material that is used to produce sample of naphtha. So naphtha is the fraction of crude oil. So the raw material is a crude oil. Crude oil have a different fractions like natural gas, petrol, naphtha, diesel oil, fuel oil, lubricating oil, and bitumen. Next part. Compound V is found in naphtha and it has a molecular formula of C10H22. So if you look at its molecular formula, it is CnH2n plus 2. So I can easily conclude that it must be an alkane. V is heated at high pressure in the absence of air. An equal number of moles of ethene, propene, and W are made. Okay, so absence of oxygen and we are getting a smaller product. It means that the cracking is performed over here. W is a compound made of straight chain saturated molecule. So we got to know about W, that W is an alkane and a straight chain. Name the process that describes this reaction. So as we have discussed that it is a cracking, so you may write cracking over here. Is this clear? Yes. Okay, now deduce the structure of W, draw its structure below. Okay, so we have a C10H22 on cracking. It is producing equal number of ethene. Ethene is C2H4, propene C3H6. Now out of 10, how many carbons are left? 5. And out of 22, 6 hydrogens are placed, sorry, 10 hydrogens are placed in these two, 4 in ethene and 6 in propene. So we are left with the 12 hydrogens, so C5H12. If you look at this formula, it is also have this general formula, which means it's an alkane. So it means I can easily conclude that this compound is W. Is this clear to everyone? So
Yes,
if I
sir.
have to draw the structure, so CH3, CH2, 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 and CH3. So C, it becomes C5H12. Is this clear?
फिर हम skeletal भी draw कर सकते हैं ना?
जी, उन्होंने structure बोला है तो it can be displayed skeletal or this one, but you can't write just C5H12 because they are asking for structure. So if you just write C5H12, then you will not be marked. Okay. C part. Propene is separated from the mixture and heated in air in the presence of a catalyst. Propene oxidized to X, which contains two functional groups. Okay. Effervescence is seen when Na2CO3 is added to X. From this, what I can conclude about X, that X may have carboxylic acid. Let me recall you again. If I have a sodium metal and let's suppose I have a sodium carbonate. So with these two inorganic substances, with sodium metal, alcohol, and carboxylic acid both react. But with sodium carbonate, only carboxylic acid out of all the organic compounds that we have studied react with sodium carbonate. And out of all the organic compounds that we have studied, only sodium metal will react. Oh, sorry. Only alcohol and carboxylic acid reacts with sodium. Now, identify the functional group present in X which is responsible for this observation. So we have already concluded that it is carboxylic acid. Is this clear to everyone? Yes, if anybody have any doubt, kindly ask.
सर ये प्रॉपर्टीज कौन से चैप्टर की हैं?
It is in organic. When we are going to study carboxylic acid, then we will discuss this thing. But you can make this note. Now, identify a reagent which could be used to show that X contain carbon-carbon double bond, include relevant observation. So,
Aqueous bromine, orange to colorless.
yeah, good. Abdullah, good. So, for a carbon-carbon double bond, we always use aqueous bromine. So I add aqueous bromine. Okay, sometime remember, instead of aqueous bromine, marking scheme, bromine water is written, so that is the same thing. So add aqueous bromine. And then you may write that solution turns from, as I have told you earlier, you can either write orange or brown or red. These three colors are accepted for aqueous bromine. So solution turns from orange to colorless. Is this clear to everyone? Now, X reacts with another reagent to form Y. Okay. Molecule of Y react together to form addition polymer Z. The diagram shows the repeat unit of polymer Z. Okay. So if anybody have any problem in this skeletal formula, so C Z can be a carbon bonded to a second carbon, and then we have a two empty bonds on the first carbon. That is the first carbon and that is the second carbon. Okay. So the carbon number one have two hydrogens bonded to it, and carbon number two have one hydrogen bonded to it, and on the other side there is a C double bond O, then O negative and Na positive. Now Draw the structural formula of monomer Y. So if it's an addition polymer, so addition polymer always a compound or a molecule having a carbon-carbon double bond can undergo addition polymer. So if you have to draw the monomer of the addition polymer, you first identify the repeat unit. Then between those two carbons which have a empty bonds, you make a double bond and draw the whole structure as it was in the polymer.
सर इन्होंने ब्रैकेट बना के खुद ही रिपीट शो कर दिया।
जी हाँ. So you have to do this only. And when you are drawing the monomer, remember you don't need to draw the empty bonds on both sides, but the carbon-carbon double bond must be drawn in the monomer. Is it clear to everyone? Yes, if anybody have any confusion, kindly ask.
सर मोनोमर्स में सिर्फ डबल बॉन्ड लगा देते हैं।
Yes, when it's an addition polymer, then what we need to do, we need to do two things: a double bond between those carbons which have an empty bond and remove the empty bonds. Okay. Yes. Is it clear to
Yes, sir.
everyone? Now, E part, polymer Z is useful because it absorbs large amount of water. However, there are problems associated with the disposal of products containing polymer Z. Combustion is not an appropriate method to dispose of pure Z because the process releases harmful gases. Some of these gases contribute to enhanced greenhouse effect, and that is carbon dioxide gas. And as Z have a carbon, so when we combust it, we for sure get carbon dioxide. Identify a gas released during the combustion of Z which contributes to the enhanced greenhouse effect. Okay, so that's what they are asking. So I may write carbon dioxide over here. Now,
कार्बन मोनोऑक्साइड।
let me read the question. Yeah, might be. Identify another gas which could be produced during the combustion of pure Z. Describe the consequences other than the enhanced greenhouse effect of its release into atmosphere. Yes, because sometimes there must be a small amount of oxygen. So some of the molecules or some of the carbon atoms may convert into carbon monoxide. Good, Abdullah?
Acid rain consequence.
No. Carbon monoxide doesn't, contribute to acid rain. Carbon monoxide is a toxic gas. It is harmful for health. It's a poisonous gas. So the consequence will, you can say that it is poisonous gas or it's a toxic gas.
सर एसिड रेन में कौन सी वाली होती थी?
Sulfur dioxide and nitrogen oxides contribute to acid rain. Now, question number 6. Propene C3H6 reacts with water in the presence of an acid catalyst to form an alcohol with the molecular formula C3H8O. Name the type of reaction. Yes. See, we have a one molecule C3H6 that is reacting with water and forming C3H8O. Yes, can anybody identify the type of reaction by looking at the equation?
Addition.
Addition reaction. Very good, because there are two reactants and we are getting one product as the atoms of both the molecules combined with each other. So it's an addition reaction. Now, name the catalyst used and state conditions needed for this reaction to occur. So,
Platinum, nickel.
no. Platinum nickel is when hydrogen reacts with an alkene. When
नहीं,
water reacts with alkene, it's an acid catalyst. So it can be phosphoric acid or it can be sulfuric acid. You can write any one of them. Phosphoric 5 acid or sulfuric acid.
सर ये 5 लिखना जरूरी है?
Sorry?
ये जो फॉस्फोरिक 5 है ये लिखना जरूरी है?
I think अगर ये याद नहीं आ रहा किसी को तो it's better कि आप जो है just phosphoric acid लिखें. And then in the bracket write the formula. But I think phosphoric acid is also more than enough. Okay. Condition.
सर हीट होती है.
Yes. Heat or heating.
लेकिन सर उसका वो एग्जैक्ट डिग्री सेल्सियस लिखना जरूरी नहीं है.
Nahin, that is the good thing for you people, that there is no need to remember the temperature. You need to remember that we have to heat, we have to apply the pressure. That's it. But for the oxidation of primary alcohols, you have to remember that whether it is heating followed by distillation or heating followed by reflux, heat under reflux or heating followed by distillation.
सर जहाँ पर आपने मेंशन करे हुए भी एग्जैक्ट टेम्परेचर वो भी नहीं याद करने.
नहीं, वो भी नहीं याद करना है वैसे.
सही है.
Complete the table to show the number of sigma bonds and pi bonds present in C3H6 and C3H8O. So C3H8O is an alcohol, right? Because steam is added to an alkene. So C3H8O would be 3 carbon atoms. I'm not drawing the hydrogen, only hydrogen that is bonded to H. If we look at C3H6, there are 3 carbon atoms and it's an alkene. So there is a double bond and the empty bonds are the hydrogens. So if we look at C3H6, how many sigma bonds are there? Can anybody count and tell me? Yes, in C3H8, how many sigma bonds are there? This is sigma, 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 and out of these two, you can represent any one sigma. So in total, we have 8 sigma bonds, and this one is a pi bond. So 1 pi bond. Is this clear? Now, if you look at alcohol, all bonds are sigma bonds. There is a no double or triple bond over here. So it means there must be no pi bond. So if you count the number of bonds, this count is 11. So 11 sigma bonds and 0 pi bond. Is this clear to everyone? Yes.
जी सर.
Okay. The reaction of propene with water occurs in two-step mechanism. In step 1, C3H6 reacts with a catalyst, H positive, to form a carbocation. Draw the structure to identify more stable and less stable carbocations which can form in step 1. Explain your answer. Okay, So I hope you all remember this thing because I have discussed this type of carbocations in detail. So see, let me recall you again. Propene is CH3, CH double bond CH2. So there are two possibilities of carbocation. One is CH3, CH, and as they have told us that hydrogen is being added. So for example, hydrogen is being added to a carbon having two hydrogens. So in that case, this carbon become carbocation. And the second possibility would be CH3 and a hydrogen added to this carbon, and the terminal carbon become a carbocation. So which one is more stable?
Yes, ma'am.
Yes, Abdullah, can you repeat?
बेसिकली इसमें मेजर माइनर की बात हो रही है ना, मोर स्टेबल वाला
Major
major
product form karega, yes, and less stable wala minor product form karega. So which one is more stable, the one on the left or the one on the right?
right.
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 Right, very good, because if you see this carbon have a one hydrogen and two methyl groups, so it is a secondary carbocation. And if you look at this carbon having a two hydrogen bonded to it, so it's a primary carbocation. So for more stable, I would draw this CH3, C, CH3, and a H and a positive charge on that carbon. And for a less stable carbocation, CH3, CH2, sorry, it would be CH3, and CH2 with the positive charge over here. Now you need to write the explanation. So I can write that more stable carbocation is bonded to one hydrogen atom, one hydrogen, and two alkyl groups, as it has more alkyl groups which cause more positive inductive effect, because the more the alkyl group, the more the electron induces to this positively charged carbon to stabilize its charge. Making it more stable. Is this understandable to everyone?
Yes, sir.
Okay. I don't know, but in this paper, the organic is easier. Name the major organic product formed from the reaction of propene with water. So if you see, if this is the major, more stable carbocation, so it will leads to major product. So in that major product, the OH group is going to bond over here. And in this case, we will get the minor product and the OH is going to bond over here. So here the OH is bonded to carbon number 2. So the name of the major product would be propane 2-ol, and the name of the minor product would be propane 1-ol. So I have to just write the name of the major product. So I will write propane 2-ol. Is this understandable to everyone?
सर
जी.
सर हम हाइड्रोक्सी का नाम जब देते हैं ना जब नाइट्राइल ग्रुप के साथ होती है.
Yes, we will write hydroxy in the prefix for alcohol when the structure contains alcohol along with nitrile, aldehyde, ketone, or carboxylic acid.
ओके सर.
Okay. Now, 2-bromopropane reacts to form propene. Okay. Which reaction would it be? See, 2-bromopropane. Propane means 3 carbons, and on a second carbon there is a bromine, and here it is converting into propene. Yes, can anybody recall the type of a reaction?
Elimination reaction.
Elimination reaction, very good. It's an elimination reaction. Hydrogen, bromide, and water. Okay. Under certain conditions. Name this type of a reaction. So we already figured it out that this is elimination reaction. Describe the reagents and conditions. So if you recall, can anybody recall that reagent?
Sodium bromide.
No. We react it with sodium hydroxide or potassium hydroxide. And if you recall, we say ethanolic sodium hydroxide or ethanolic potassium hydroxide. So it means that ethanol would be the condition because it's a solvent. And the second condition would be heating. So we will write ethanol and heat. Is this clear?
Yes sir.
Okay. So we have ended the paper. Just give me a minute, please. So in the next class, I'm going to start the new paper.